We have got another concept, that's implicit differentiation, in chapter 2, the last section, which is section 6. I'll skip section 5 because it's about something that has got extra rules. You do not need these ones for me. So I'm just moving to section 6, implicit differentiation. Implicit differentiation is not nearly, it's the same thing as the differentiation that we have studied previously in the sections 5, 4, 3, 2, 1. Okay, so it's easy. You just need to concentrate a little bit more. Instead of only differentiating x here, we also have got to differentiate y. In general, functions are written in two ways. Let me go to the functions before going to the differentiation. We have got explicit form, okay? Explicit form. What's explicit form? Y is equal to, for example, x squared plus 3x minus 1. That's explicit form. Why is it called explicit? Because y is explicitly defined as a function of x. Y is alone on one side and everything else is on the other side. That's called explicit form. And the differentiation that we have studied so far were all described for explicit form of functions. And we also have got implicit form of a function. What is implicit form? In that form, x and y's are mixed up together and written just in a general way. Okay, for example, if we've got xy plus y squared minus x plus 3 is equal to 0. If you look at that function, x's and y's are mixed up together. Sometimes it's even not easy to write that function that we have got in an explicit form. So you just have to leave it in its implicit form. So that is implicit form of a function written. Okay, x's and y's numbers are all mixed up together, and that one is an explicit form. Now we are coming to the differentiation of these kinds of functions. If you've got an implicit form of a function given to us, how can we take its differentiation? Of course, we are using the same rules that we have studied previously, only with a little bit adding like spices to that function, to that differentiation. Okay. I have got no explanation because explanation needs to be written in a general form, and general forms are always hard for you to understand. So I will just skip to an example and to clarify it more for you. Here, if you have got an example x squared plus y squared, that's equal to 3x plus y plus 5. If you look at that function, it's written in an implicit form, not an explicit form. So we are taking implicit differentiation of that function. In previous examples, we were writing y prime is equal to, for example, 2x plus 3, and that's equal to 0. But here, they are all together, so we do not have y prime alone to be written. What is the derivative of x squared? Just think about it that we have studied previously. X squared, the derivative is equal to 2x, okay, plus. What is the derivative of y squared? Think about y squared as the x squared, okay? What's the derivative of x squared? It's equal to 2x. What's the derivative of y squared? It is equal to 2y. So you are doing the same procedure, the same idea that you have studied for explicit form. That's equal to 2y. But the only thing that makes a difference here, you are also adding and multiplying it by y prime. Whenever you see y, okay, whenever you see y and you're taking the derivative of that y, you have to multiply it by y prime. After taking the derivative of y, you have to multiply it by y prime. Okay, that's the only difference between explicit forms that we were finding the derivatives and these ones. Okay, of course, the general idea is finding the derivative is different, but the rules are the same. Okay, so that one is equal to, the derivative of 3x is equal to 3 plus the derivative of y. If you remember, derivative of x is equal to 1. Derivative of y is also equal to 1. But we have to also multiply that one by what? By y prime. Okay? Whenever you take the derivative of y, you must have y prime right next to it. And plus, that's 0. Let me simplify this one or write it in a nice way. That's equal to 2x plus 2y. Y prime is equal to 3 plus y prime. If it is required from me to find y prime, okay, I will here write find y prime is equal to what? You have to move those y's that are together on one side and everything else to the other side, because here y prime is required from you. It's true that we have differentiated that concept, but if it is required from you to find y prime, you have to rearrange the differentiated form into something written in y form, y prime form. So I'm taking that y prime to the other side to collect it with that y's, and I'm taking the other things to the other side. Okay, so that one will be 2y y prime minus y prime is equal to 3, and taking this one to the other side, that would be 2x. Now if you see between this term and that term, I have got y prime is common. So y prime, what remains here? 2y minus what remains here? 1 remains. That would be 3 minus 2x. Dividing both sides by 2y minus 1. Why do I do this division? Because it's required from me to find y prime. To find y prime, I have to get rid of that part. So this part and that part go together. So y prime is equal to 3 minus 2x. And that is the implicit differentiation. So what is difference here? You are again using the same rules that you have used previously in the other sections, except for when you're taking the derivative of y, whatever y is, you are multiplying it by y prime. If it says differentiate that expression, it is okay to leave it here, okay? It's okay to leave it here. But if it says find y prime, you have to also do those steps to leave y prime alone and find the solution that is required from you. Now we are moving to the first example that is given in the course material, that is 261. It says find y prime if x squared y plus y squared is equal to x to the power of 3. So here it doesn't say differentiate, okay? It says y prime, so you have to do further steps to get to the solution. Here x squared y, you consider this one when x's and y's. If you look at this function, x's and y's are separate. X is alone, y is alone, x is alone. It is okay. In the general concept, they are mixed up together, but no x's and y's are multiplied together. When x's and y's are multiplied together, you're considering multiplication rule, or let me say product rule. You consider that this one is the function f and that one is the function g. So you're using product rule, that is f prime multiplied to g plus, so here let me write it, that would be f prime multiplied to g plus g prime multiplied to f. Okay, so whenever you see x and y's multiplied together, you have to use product rule. So what is f prime? F prime is the derivative of x squared, that would be 2x multiplied to g. G is y. Okay, please, as I told you, when you're doing product and quotient rule, please put each part, each term into a bracket. Then I have got plus from that sign. Then the derivative of g. What is derivative of g? It is y prime multiplied to f, that is f equal to x squared. Then I have got that plus sign, okay? That plus sign is this one. Do not confuse it with that. That one belongs to that here. Okay? Plus derivative of y squared is equal to 2y y prime, okay? And that one is equal to 3x squared. That's the differentiation. It's required from us to find y prime. So we are putting all the y prime terms in one side and all of the other stuff to the other side. Now, this one contains y prime, so I will leave it here, y prime x squared. That one plus 2y y prime is equal to, I'm taking this one to the other side. Okay, that would be 3x squared minus 2x y. Now, y prime is a common factor between this and that, so x squared remains here plus 2y, and that one is equal to 3x squared minus 2x y. To get rid of that bit, we are dividing both sides by x squared plus 2y. Dividing this side by that will leave me y prime alone, okay, and that one would be x squared minus 2xy all over x squared plus 2y, and that is the required result of y prime. As I told you, if it says differentiate that part, it is okay. You can leave the solution just like that. The first step is the differentiation. You do not need to do further steps, but of course definitely I will also ask for y prime, so you are writing y prime like that. You have to do further steps. It's just simplification, just doing algebraic operations, and you will get to the result that's required from you. Okay, let's move to another example. In that example, it's required from you to find the slope of a tangent line of that circle at the point 3 and minus 4. What is the slope? Slope of a line is required from me. So slope, you know that means the derivative is required from you. The derivative at that point is required from you. So first, you're finding the derivative and you're inputting this one into the function that we have got. You will get the required result. What is the derivative of this one? It's equal to 2x plus 2y, y prime is equal to 0. We need slope y prime to be alone, okay? So we are moving this one to the other side. 2y, y prime is equal to minus 2x. I need y prime to be alone, so I'm dividing both sides by 2y. Okay, so that one gives me what? Y prime is equal to minus 2x over 2y. This one and that one cancel each other, okay? Now I have to find y prime at the point of 3 and minus 4, because it's required from us to find the slope of that tangent line at 3 and minus 4. So I'm inputting that point into y prime. What will I get? Minus 2 multiplied to x, that's equal to 3 over 2 multiplied to minus 4. That minus goes with minus, makes it positive. That 2 cancels out with that 2. And 3 over 4 will be remained. And also you can also skip it from here, cancel it from here to divide it by 2. So that will be minus x over y. So that's the slope of the tangent line to the curve x squared plus y squared equal to 25 at that given point. We've got another example. 263. It says find all points in the curve where the tangent line is horizontal to x squared minus y squared equal to 2x plus 4y. Again, what do we have? We have got where the tangent line is horizontal. Tangent line is horizontal. What does tangent line is horizontal mean? That means m is equal to 0. What does m mean? That means the first derivative of the function. So even if it doesn't say find y prime, here it says find the tangent line where the tangent line is horizontal. That means find those points that y prime is equal to 0. So you have to find y prime in that equation. So taking the derivative of that one, the derivative of x squared is equal to 2x, derivative of y squared is equal to 2y, y prime, and that's equal to 2 plus 4y prime, okay? The derivative of 4y is equal to 4, and of course y prime right next to it. Again, we are taking those numbers, those terms that have got y prime to one side and the others to the other side. So that would be minus 2y, y prime, minus 4y prime, okay? 2 minus 2x, okay? That one it is. That one is this one. This is the 2 and minus 2x. We are taking y prime out alone, okay? Minus 2y remains here, minus 4 remains here, and that would be 2 minus 2x. Dividing both sides by that bit, so y prime is equal to 2 minus 2x over minus 2y minus 4, okay? So that is the derivative of the function. What is required from us? To find those numbers that makes the tangent line is horizontal. That means y prime is equal to 0. So y prime is equal to 0. What does that mean, y prime equal to 0? That means 2 minus 2x over minus 2y minus 4 is equal to 0. How do you solve that equation? We do cross multiplication, okay? That one is over 1. So 2 minus 2x multiplied to 1, okay? 2 minus 2x multiplied to 1 is equal to, this part multiplied to 0 is equal to 0. That's easy to solve. We are simply taking this part to the other side. So 2 is equal to 2x dividing both sides by 2 to find the x, so x is equal to 1. So that function has got a line that is has got a tangent line that is horizontal at x is equal to 1. Okay, I hope you would understand. Hope you have understood the subjects, the concepts that I have explained for you. We are done with section 6 and we are also done with chapter 2. I hope it was a nice chapter. I think it was a good chapter, an easy chapter for you because you're already familiar with those concepts and notions that we have studied. Have a good time, have a nice time, enjoy watching the videos. Hope you would understand everything, and bye-bye.